All right, class. I wanted to make a quick video to talk a little bit about how we ended class in regards to our Involute gears from Wednesday. So after playing with SOLIDWORKS for a bit, I found a good way, well, at least a way to be able to get our Involute gear profile without having to specify both the top and bottom Involute curve. But the way SOLIDWORKS handles these equation-driven curves is a little bit funky. And so you have to do a bit of work to try and get that in. And I'm not entirely sure it's not better just to define both curves. So let me walk through and show you how I solved this. The first thing that I did was that I made a sketch that just has my guide circles here and my involute curve. I made that separate because I want this curve to have no other constraints defining its position. So that way when it updates, it's not going to be likely to break anything else that might influence the curve. And then on top of that, what I did was I drew half of the cutout with the angle as a function of my pitch. So this actually gives me the appropriate cutout with using an angle in radians. So just to be clear, this needs to be in radians for that to make sense. I could convert to degrees as well to have it in degrees if I really wanted to, but I just changed my unit system to radians. And this is just a straight line going halfway across. After making that cutout, I then mirrored the cutout so that I get the full cutout of the circle, and then I patterned it. And this worked good, and I was even able to go in and use the save as option to save this as my gear out, as you can see right here, and then change all the parameters, including the parameters of my equation inside this spline. And after I made all those changes, it was able to generate the gear, and that worked great. Um, After doing that, I put this back into my assembly, and I was looking at my gears in the system here, and I wanted to show you all that even after updating this to have the appropriate gear ratios, I'm still getting a little bit of a contact issue in my gears. Oh, it's still suppressed. Where my gears are not quite clearing each other. So you can see we have a little bit of an interference there. And in fact, if I lower my interference detection, you can see I have interferences on this position and this position. And since this is on the top side of this gear and the bottom side of this gear, it's not just that the alignment is off, it's actually these gears are not going to clear each other the way that they're supposed to. So given that that wasn't working, I dove down a little bit of a rabbit hole and I looked at gear pressure angles, and that led me to the base circle of different gears. And I found that you actually have to have the base circle, which is the circle that we were using to start the involute curve in our gear assembly. So this circle right here, which go back to one of the individual gears, we can see this a little bit better, is where we're starting our involute curve, which is right there. It has to be a function of the pitch angle, and we've just used a constant offset, or sorry, it has to be a function of the pressure angle, and we've just used a constant offset. So what this means is that this offset is too big when our gear is small and too small when our gear is big, and only really works for one size of gear, which doesn't help us very well. I didn't go through and remake this to have that position be a function uh, of the contact angle, but I wanted to look and see how this actually works out. And this is kind of a nice website to let you look at different gear sizes and see how they interfere. And I thought it was kind of an aha moment on here is that I realized that if I had a zero pressure angle, or if I had a tooth that was really large, these things would not work. So as an example, if I make this gear on the right very, very big, oh, sorry, that was the one on the left. Let's go back and make that one smaller again. It centers on that first gear, so I'm gonna go to the second gear. I'll make this really, really big. The the distance here, right, this base circle distance, which is what's showing you with this line, gets very large at these very big gear sizes. And if this was a rack, basically a straight gear, uh, the involute of a rack would be a straight line with a zero pressure angle. And so you can see that if I make this pressure angle get really low, what this is doing is it's setting this angle of this tooth. So if this was a straight gear, just a rack, which this simulation doesn't do, um, the pressure angle would determine the angle of these faces and they would be straight lines. So I can't have a gear that has a pressure angle of zero, which means I can't have this offset be constant. It has to change. And you can even see, even with this simulation, there's some interference inside these gears, even though they're using all the correct values for, kind of a standard gear profile. Uh, so I thought that was kind of interesting. It was worth noting. So we can talk about that more in class if you'd like. But just wanted to do a quick update video. Hope you're all having good work or having good luck with your projects. And let me know if you have any questions. Thanks. Bye.